Hello, my name is Artem Khovrat, and today I want to present the result of our investigation, application of neural networks to identification of fake news. As of today, given the general political destabilization in the world, the number of fakes has increased in absolute and relative terms. Some of them can be attributed to the incorrect subjective perception of real information, but a significant number is the result of military propaganda. Before the beginning of the full-scale invasion, a vivid example of manipulation with fakes was the information about the spread of coronavirus from China, in particular the story about eating bats and the global conspiracy regarding the vaccine. The trend towards combating such information is generally positive, but the problem lies in determining whether the information is fake or not. If the decision is based not on facts but on expert assessment, for example, then such situation can be considered manipulative. For countries, the process of identification fake news can be automated using artificial intelligence. Initially, naive Bayes or SVM were used as the basic method, but with the development of neural networks, convolutional and recurrent neural networks gained the most popularity. It's worth noting that given numerous studies, these models can give different results depending on subject area. Therefore, it was decided to consider the effectiveness of using these models to identify fake news, to optimize their selection during the development of an appropriate software system. Brief information about the main elements of the work is shown on this slide. First of all, the task of identifying fake news concerns the process of NLP, so for now we will focus on how it's possible to detect whether this or that news is fake. We can use a dataset about 2016 presidential election in the United States. It contains more than 20,000 views, of which 12,000 are faked and 8,000 are real. The real news in this set is data from news websites such as New York Times and Washington Post. At the same time, we will consider this dataset from the perspective of computational linguistic, psychological positioning, lexical diversity, and sentiment analysis. The first thing to note is that fake news has fewer words on average than real news. In addition, the range of words in fake news is much larger than in real data. Despite fewer characters and the sentences themselves are shorter in fake news. Other similar patterns are shown on the slide. The mood in real and fake news also is significantly different. As can be seen from the figure on the slide, both the median value and the standard deviation indicate that fake news is more negative. Several reasons can be identified that would explain this phenomenon. First, the creation of false information is aimed at inciting the population. Accordingly, the mood to the text should have a negative color. Having reviewed the main lexical regularities, we can proceed to the review of neural network architectures. Let's start with convolutional one. They consist of three types of layer: convolutional, subdiscretizing, and perceptron. The first one is based on a set of filters that pass through the entire depth of the input volume data. While passing through the network, the filters slid over the width and height of the input data, during which this color product between the filter entries and the input information is found. As a result, a two-dimensional activation map is formed. The screen shows the list of hyperparameters that need to be configured for the network. And the next slide is CNN architecture for next analysis. You can see that we need use only text vectorization. Having considered the architecture of convolutional networks, we can move on to the recurrent networks. The figure on the slide depicts the recurrent boundary at each point in time, showing the presence of three layers: input, hidden, and output. The learning process occurs by back expansion in time, when new weights obtained as a result of the current processing. The classical architecture of the recurrent network is not suitable for the full processing of text information. Thus, it was decided to consider the Afanasieva architecture shown on the screen. Let's proceed to consider the processing algorithm. First, all non-literal expressions are removed from the text. Then, those words that do not carry informational load. The next step is decrease the level of the linguistic variability. For this, timing operation and lemmatization are used. After processing the text, a dictionary is created that is necessary for the correct definition of TF-IDF characteristics. To take into account the emotional coloring of words, the next step is to find a frequency polar characteristic for each word by multiplying the TF-IDF and polarity indicators. In this case, the polarity is defined as the degree of fakeness based on the previously analyzed dataset. Having considered all the necessary information, necessary structural elements, we will proceed to the experiment. You can familiarize yourself with the experiment plan on the screen. As a target dataset, it was decided to use data about the election in the United States in 2019 and news from Telegram channels about the war in Ukraine. The average result of the experiments are shown on the slide. As we can see from the presented data, the CNN models work faster than LSTM, but give a less accurate classification result. Given the proposed efficiency comparison rule, the stated probabilities of errors of various kinds and ways to overcome the disparity between algorithms, the resulting efficiency gains can be considered insignificant. As further goes for deepening the research, it's proposed to consider the possibilities of combining recurrent and convolutional network. And as a result of this research, we can say the filter of fake news and the efficiency of using artificial intelligence tools was their detections were analyzed, and the relative efficiency of using recurrent neural networks compared to convolutional neural networks is proven. You can see all references, part of references, on the slide. Thank you for your attention.